Hello everyone, this is going to be our first video of calculus. So the first thing we're going to be concentrating on is differentiation, and differentiation starts on chapter 23, which is on page 434 of our book. So differentiation, what it means is we are looking at a rate of change. Now we've seen the words rate of change before in terms of a rate of change of a line or rate of change of a vehicle moving is the slope of a line. So that's all that we're really looking for. Differentiation is finding the slope, but unfortunately we're not just going to be dealing with lines, we're going to be dealing with curves. Now when we're looking at a line, it's fairly straightforward. We can use the slope formula y2 minus y1 over x2 minus x1 that we learned in coordinate geometry at junior cert to find the slope of our line. Where it gets a bit more difficult, if we're dealing with a curve, at different points on this curve, the slope will be different. Now, at this kind of curve, we're dealing with an increasing curve. So as we are looking at progressing further along the curve, the slope is getting more and more steep, all right? So differentiation is a method of allowing us to find the slope of any given point on this curve, and it'll give us a formula to do that. All right, so the first thing we need to look at in terms of differentiation is how to differentiate from first principles. So this is a method that we need to learn off and apply to different formulas. Now, it involves a number of steps. You have to learn off the formula and learn off the steps involved. And it is a very handy question if it does come up on the Leaving Cert, because it's normally worth between about 15 to 20 marks if it does come up, and it's normally in part of a short question. So the formula involved is f dash x is equal to f of x plus h. Oh, sorry, I've forgotten the most important part. The limit as h approaches 0 of f of x plus h minus f of x all over h. So we're looking at the limit of this fraction here. Now, what's going to be very important is this section here, the limit as h approaches 0. If you forget to apply this into your differentiation from first principles question, it is a major loss of marks. That is key in terms of gaining full marks in this question. So in terms of the steps involved, the first step is we find f of x plus h. And that simply involves, so we're given a function. It'll make more sense once we look at an example of a question now in a minute. But we are given a function, and the first thing that we do is we replace the x in the function with x plus h. And we do have to multiply out and simplify. The next thing that we do is step 2. We find f of x plus h minus f of x. So our step 1 minus the original function. The third step is divide by h. So we have f of x plus h minus f of x all over h. And our final and fourth and final step is to apply the limit as h approaches 0 of our fraction. All right, so we're going to look at a couple of questions in terms of how to apply it and look at how it looks in a question. So for the purposes of this, we're going to look at page 448. So it's exercise 2 on page 448. And we're going to look at question 1, part B. All right, we'll start nice and easy. So in question 1, part B, we're given the function f of x is equal to 3x minus 5. All right, so we're looking to use differentiation from first principles, and I'll write the formula up here again. F dash x means the derivative of. So that's what we're looking for. When we're looking to differentiate a function, we're looking for the derivative. And that is the limit as h approaches 0 of f of x plus h minus f of x all over h. So our f of x function is 3x minus 5. First thing we do, step 1, is we find f of x plus h. Now with these questions, the left-hand side that I'm writing down here is as important as the right-hand side, so as important as the working. So make sure that you do the steps on the left as well as on the right. So we simply replace the x in the function with an x plus h. So anywhere we see an x, we replace it with x plus h. We multiply out and simplify. So we have 3x plus 3h minus 5. So that's our fully simplified step 1. Step 2. We subtract our original function. So that's going to be our new function of 3x plus 3h minus 5 minus our original function of 3x minus 5. When we get rid of the bracket, that becomes minus 3x and it becomes plus 5. So we can see now 3x minus 3x is 0 and minus 5 plus 5 is 0. So we are left with 3h. Third step, we divide by h. So we're looking at f of x plus h minus f of x all over h. So that is 3h divided by h, which gives us 3. Final step, we apply the limit as h approaches 0 of f of x plus h minus f of x over h, and that gives us 3. So our derivative, f dash x, is equal to 3, and that's our answer. So these are our 4 steps that we have to go through. Now I'm going to go through a slightly more complicated one just to give you an idea. So I'm going to leave my steps here on the left-hand side because these 4 steps are key in terms of the work that you need to show to answer your question. So this time we're going to look at, I'm going to make one up. So we're going to look at this function here. So we're going to look at 3x squared plus 4x minus 5. So this is our function, our original function. First thing we do, step 1, is find f of x plus h. So we replace the x with x plus h. So it's 3 bracket x plus h squared plus 4 bracket x plus h minus 5. So because we have an x squared and an x in this function, we have to replace both with x plus h. Multiplying out, we have 3 by x squared plus 2xh plus h squared plus 4x plus 4h minus 5. And simplifying, 3x squared plus 6xh plus 3h squared plus 4x plus 4h minus 5. Now, to save a bit of time, when we're subtracting our original function, all we need to do is write the original function directly underneath. So what we can see here, 3x squared minus 3x squared will cancel each other out. We can see that 4x minus 4x will cancel each other out there. And minus 5 minus minus 5 is plus 5, so minus 5 plus 5 will cancel out there. So what we are left with is 6xh plus 3h squared plus 4h. So that's what we're left with in step 2 after we have subtracted the original function. Next, we need to divide across by h. So again, bit of a shortcut, we can draw a line, divide by h. So in a fraction with several parts to the numerator, you must divide each part of the numerator by h. So 6xh divided by h is 6x. 3h squared divided by h is 3h. And 4h divided by h is 4. Next, we apply the limit. So this is a bit different to the previous example now. So when we're applying the limit as h approaches 0, if there is a h in our function here, we replace that h with a 0 as h approaches 0. So we're looking at 6x plus 3, replace the h with a 0, plus 4. So my answer is f dash x is 6x plus 4. And that's how we look at differentiation from first principles. All right. So that's video 1. I'm going to assign you some work on Google Classroom. So I want you to go through this, watch this video carefully and have a look at the assignment. Look at the start of chapter 23 in your books, and I'll give you some questions to do based on that. Thank you.